Okay. Sai Chindu has a question on LinkedIn. What is dimensionality reduction technique? And what do you mean by underfitting and overfitting? These two questions are slightly off track with respect to KNN. We will answer that towards the end, certainly. And in the interim.
Yeah, maybe, Bharani, we can also direct Sai Chandu to the video there in the series where we discussed about dimension reduction specific topic. Sai Chandu, I would recommend you to go to that particular topic in the series, and you should probably be able to get all those details.
Yeah, absolutely. Well said. Well said. So there are a couple of videos which we have, one on dimensionality reduction, another on the entire machine learning pipeline, not machine learning pipeline, I would say machine learning primer for that case. So both of those will be shared by our team to you, and you might want to reap benefits on that. So the next question pertaining to KNN is, this KNN algorithm is called as lazy learner, like a lot of students, right, Sharad? So why is it called as lazy learning algorithm?
Yeah,
and yeah, like me as well.
Yeah, it's always said that lazy people are more smarter. So yeah, I would be taking that as a compliment.
You're lazier than me, that is.
Well, so it's not just lazy learner that is the name that is given to KNN algorithm. It is also called as memory-based reasoning, example-based, instance-based, case-based reasoning, or rote learning, right? So these are all different names. Of course, the lazy learner is more popular with respect to the catchy words and easy understanding, easy interpretation. This is because, as I mentioned, KNN algorithm is not recording the learning process. Whatever we are trying to train on the historical data, it is not trying to learn the pattern. It just does the distance calculations. And whenever we ask a question to the algorithm, it takes the distances and then gives the results. Unless until we measure the distances, when we predict, only then the calculations happen. Until then, it waits. And this basically puts a lot of computation burden when you have larger data sets. Now imagine the distances would have been stored, calculated and stored with respect to your historical data, right? Now, if that would be the scenario, then distances would be readily available. And when you ask the question with respect to that record, it would probably be very easy for the algorithm to return the most similar records. But that is not the case in KNN. It is not built that way. Whenever new record comes in, only then the distances can be calculated. And only after distances are calculated, we will be able to identify the shortest distances, and then we will be able to tell whether what is the class of that particular new record. So that is the reason why it is called as a lazy learner.